Good afternoon. This is Chris. I am presenting the Blob Project. My partner is Philip Ferreira. Discovery. In 2014, a climatologist out the University of Washington, Nick Bond, dubbed a patch of unusually warm water off the North American coast the Blob, or as it is called now, a marine heat wave. What is it? It refers to a remarkably warm water anomaly that can stretch from Alaska to Mexico. It peaks during the winter of 2014 and summer of 2015, where sea surface temperatures were 1 degree Celsius to 4 degrees Celsius, higher than the average along the west coast of North America, and can penetrate as deep as 180 meters below the ocean surface. Proceeding in several phases, it begins as a single patch in the Gulf of Alaska in 2013, spanning at least 1,600 kilometers horizontally and 90 meters in depth. A second patch of anomalously warm water began to appear farther south in the spring of 2014, ultimately spanning from Oregon to Baja California. Both the magnitude and geographical extent of the marine heat wave varied seasonally and annually. The reduction of heat fluctuation from the ocean has weakened typical winter storm and wind patterns. This increased ocean stratification and altered processes such as wind-driven Ekman transport and pumping, leading to a reduction in vertical mixing of colder deep waters with surface waters, also weakening in the horizontal advective transport of colder waters from the north, south, and the California current system, coincided with the North Pacific transition zone, a highly productive front where cold Arctic water meets warmer subtropical water, moving farther north than usual. Locations: 3 distinct patches, the first off the coast of Canada, Washington, Oregon, California, reaching to Hawaii, the second off Alaska and the Bering Sea, and the third and smallest off southern California and Mexico. Can sometimes vary in depth from 20 meters to 100 meters length and area it is in. How does it happen? One theory to the formation of the blob is a strong occurrence of the El Nino, which is the lack of movement of the warmer Pacific sea surface water westward by trade winds from the east. In some years, with the weak trade winds, the mass of warm water will stay eastward, causing El Nino. This creates an area of high pressure which doesn't allow for storms to take place, leading to further prevention of warm surface water mixing with the lower, cooler water from storms over the ocean. Effects can lead to higher temperatures of water, which affects the types and amounts of the specific food source that can be found there. Can reduce the production of chlorophyll A and phytoplankton, which support zooplankton, providing less energy to larger organisms, creating disruptions in the food web, leading to higher mortality of marine mammals from sea lions down in California to fin whales in the Gulf of Alaska. Many marine animals, once accustomed to warmer waters, are invading areas were once held by cooler temperatures. In 2015, harmful algae blooms began in May and October and grew, one of the largest and most severe HABs ever recorded. Harmful algae blooms stretching from Southern California to the Aleutian Islands. Harmful algae blooms are not uncommon in northern Pacific. Blooms occur most frequently in the late summer and fall and typically last a few weeks. But specifically, these harmful algae blooms by diatom pseudonychia, which can produce harmful toxins to birds and marine mammals. Effects: many pelagic marine fish responded to marine heat wave by expanding or compressing their geographical ranges, shifting their regional population structures, and or incorporating alternative prey into their diets. Melting of glaciers and permafrost more north contributing to disruption of the movement of circulation, salinity, acidity to the ocean. Disrupts normal weather patterns, warmer temps, drought, which then can lead to several types of disasters. The blob today. The North Pacific marine heat wave of 2019 finally decreased below our heat wave classification and ended in terms of its surface expression of January 17, 2020. It lasted 239 days and covered approximately 8.5 million kilometers at its peak, officially becoming the second largest and longest event recorded in the Northern Pacific Ocean since 1982. After the decline of NEP-19 in January 2020, a fairly large pool of anomalously warm water has remained in the far offshore region. Temperatures in the offshore pool of water surpassed our marine heat wave threshold briefly from February 21st, March 7th, 2020, and again from March 14, 2020, continuing through April 2020. And have a good evening.